Hi, Assalamualaikum and very good morning. We are from Group 1 and this video is to present our progress on computer network project. And the title for this project is scroll down, Sd-Wan for bandwidth and delay improvement on the internet. So our group members consist of Alifah, Ilyana, Sharifah, Sakinah, Sharifah, Nadhia, and me, Nurazlina. And this project is about the Sd-Wan. So Sd-Wan is stand for Software Defined Wide Area Networking. So Sd-Wan is currently considered as a technology that has the potential to revolution the use of WAN services. So it supports a new concept known as application-driven networking, where the network is expected to meet the needs of application, services, and customer. So Sd-Wan is a centralized management of wide networks, usually with a close connection to cloud computing and security. Next, I will pass to Sakinah to explain about the introduction part.
Okay, so for this part is actually talk about the general knowledge about the Sd-Wan. So Sd-Wan is actually the combination of a software-defined network, SDN, and a wide area network, WAN. So this virtual WAN architecture that allows an organization to securely connect users to applications such as MPLS, LTE, and broadband internet services. So actually, Sd-Wan secures and intelligently directs traffic across the WAN and directly to trusted SaaS and IaaS providers. So SaaS is actually stands for Software as a Service, and IaaS stands for Infrastructure as a Service. Okay, so this improves application performance and provides a high quality user experience, boosting business, productivity, and agility while lowering IT costs. So it actually directs traffic based on TCP/IP address and SCL. This is caused the rigid, complex, wasteful, and cloud incompatible. So thus, as Sd-Wan enables intelligent application aware routing across the WAN by detecting applications. So it actually break out of IaaS and SaaS application traffic to ensure the best cloud performance. And as a result, the traditional WAN is no longer suitable because it backhauling all traffic from branch offices to headquarters, including traffic destined for the cloud, introduce latency and degrades application performance. So actually Sd-Wan simplifies WANs by lowering the cost, improve bandwidth efficiency, and delivers a seamless on-ramp to the cloud. So next, I will talk about the objective in this assignment. We want to study, we want to implement, and we want to discuss the problem solution for the state-of-the-art of Sd-Wan for bandwidth and delay improvements of the internet. So next, I will pass to Sharifah Nadhia to talk about the literature review.
Okay, for the literature review, a survey has been done by some research from academic article or some research paper about Sd-Wan. So the first author is our TA2020. So the issue of or the topic of the paper is the Sd-Wan software-defined WAN, network engineering and project management. So the survey scope of this paper is to justify the benefit of the Sd-Wan towards business management and network engineering project. So from this paper, our finding from this paper is the existing technology of network, MPLS, multi-protocol level switching does not reliable, and the software-based routing significantly reduces the time for network management as it centrally managed through a cloud-based controller. For the second paper from Ida lagi, 2021, the topic is Sd-Wan is impact and the need of time. So the survey scope for this paper is to provide the concept of Sd-Wan and its relevant terminologies and the justification for the need of time in software and Sd-Wan. So the finding from this paper is the software, the SDN concept is mainly asset to decouple data plane and control plane and network switch. And for the third paper is from CGAC. The issue is SD1 architecture function and benefit. And lastly, the last paper is RCIF from Asif and Kikkanum. So the issue is AI SQL SD1 architecture as a latency critical IoT enable for 5G and beyond communication. So for this last paper, our finding is the SD1 appliances are quite fast to encrypt the data at high bandwidth and allow the public internet to transport the data. Okay, next I will pass to Alifah Ilyana.
So as a result of our findings, we noticed that there are two features that need to be highlighted for SD1. So the first one is SD1 architecture. So SD1 architecture has three different planes, which is data plane, control plane, and also orchestration plane. And moving on to the efficiency as demanded from this paper. So we did a research and found that SD1 indeed offers delay improvement and bandwidth efficiency. So as for delay improvement, SD1 is designed as such, it's outside of the data path. So the performance of the transmission will not be disrupted. In fact, as explained from 11 track 53 lecture, SD1 steers the data to the shortest path to arrive to the destination, which solve the latency problem. SD1 also detects the optimal traffic routes and trouble areas in a real time to ensure that whenever the packet sent, the delay can be reduced, hence improve the network communication. Bandwidth and efficiency, on the other hand, SD1 enables economical expansion of bandwidth by aggregating one circuit of any type from any provider to relieve the congestions of and provide faster response for even for single application flows. On the other hand, SD1 adds the secondary transport together, such as broadband or LTE, that enables the transmission to double its transport. Hence, it is a bandwidth effective. Moreover, as stated in the literature review section, instead of using MPLS, which is a lower bandwidth, factor pipes of broadband internet is used that has a higher bandwidth. Higher bandwidth means higher bit rate, which means a lot of data can be sent, hence it's actually a bandwidth efficient. So in conclusion, it is undeniable that SD1 can improve the latency and bandwidth efficiency with its own working principles and concept. SD1 definitely will build on the past successes of more mature technologies such as SDN and WAN that may hold the key to the promising future of the vast and growing global energy network ecosystem. That's all from us. Thank you very much.